Welcome back to part 4 on Intro to Right Triangle Trig. In this video, we're going to introduce the calculator, and instead of looking at the ratios for an angle, we're going to be given the angles. So the right triangle ratios of special angles are very important, and since they're used often to try and calculate things, you should probably memorize them using the tricks I'll show you as we move through the quarter. Otherwise, you can come up with triangles each time, and although it works, it's not recommended because it is so time consuming. For angles that are not special, meaning they're not the 30, 45, and 60-degree angles in the first quadrant, or the flips or transformations of them into the other 3 quadrants, then we'll use your calculator. So let's find the values of the 6 trigonometric ratios for the following angles. So we need to find sine of 29 degrees, cosine of 29 degrees, tangent of 29 degrees, and then we're going to go over to cosecant of 29 degrees, secant of 29 degrees, and cotangent of 29 degrees. So let's start out with sine of 29 degrees. First, turn your calculator on and go to mode, and arrow down until you find radians and degrees. If you leave your calculator in radians when you calculate degrees, everything will be wrong. So arrow over to degrees and select degrees. And then second quit. And now we can calculate the sine of 29 degrees. So we'll click on sine 29, enter. So the answer to this is saying that we are almost at 1/2. So we'll round this to 0.48, so 2 decimal places. Let's calculate cosine of 29 degrees. 0.87. Tangent of 29 degrees. 0.55. All right, so let's take a look at what this actually means in a sketch. 29 degrees is very close to 30. If we were looking at a unit circle, we would be looking at how the relationship between x and y correspond. And I can see that my y for sine makes sense because I'm about just under halfway up the y-axis in the positive direction. For cosine of 29 degrees, I'm very, very close to 1 in the x direction. And for tangent, if I take y over x, 0.48 divided by 0.87, I'm going to get something very close to 1/2. Now, and remember that this tangent is like y over x. If we look at cosecant of 29 degrees, we could take the reciprocal of sine of 29 degrees. Remember, because cosecant is 1 over sine. So this would be equivalent to 1 over 0.48. Secant would be equivalent to 1 over 0.87. And cotangent would be equivalent to 1 over 0.55. So let's see what that gives us. 2.06. For secant of 29 degrees, 1 divided by cosine of 29, 1.14, and cotangent. You may be wondering, could I just put 1 over tangent of 29 degrees? And you could totally do that. So let's see what that does. .80. Now, the question is, what is that? From the context of this section, we know that this should be an angle, but it does not have any degrees on it. So all we're given is this thing that's 1.4. So we have to assume that it is in radians. Before we do anything else, take your calculator, clear your screen, go to mode, and go back to radians. If you do not do this, you will have all wrong answers. It wouldn't even hurt, actually, if you were on your test and you weren't sure if you were doing the right thing. Just like go back and check your mode every once in a while just to make sure you're in the right mode. Because if you're not, oh boy, all the answers are wrong. I've never done that before. So if we have 1.4 radians, it's the same exact process. Sine of 1.4, cosine of 1.4, and tangent of 1.4. And then we find the reciprocals. Sine of 1.4 gives me 0.99. Cosine of 1.4 gives me 0.1699, so 0.17. Tangent of 1.4 gives me 5.797, which means I need to round up to 5.80. Quickly, we have cosecant of 1.4, secant of 1.4, and cotangent of 1.4. And again, I'll just calculate 1 over 0.99, 1 over 0.17, and 1 over 5.80, because remember, these are reciprocals of the first 3 trig ratios. The first one is 1.01 for cosecant of 1.4. The next one, I'm just going to go ahead and put 1 divided by cosine of 1.4, which is 5.88. And the reciprocal of tangent is cotangent, so I'm going to type this in as 1 divided by tangent of 1.4. So that is equivalent to 0.17. I think it's important to note that these are not in radians anymore. These are lengths. Remember that sine, I know I said this already, but it's so important to recognize the relationship. Sine represents your y direction length. Cosine represents the length or the distance you've gone in the x direction. And tangent represents the ratio of y over x for those distances. The reciprocals are these values for y, x, and y over x, and they are also representing distances, not radians. And it's really super easy to confuse an angle with a distance. So these are all distance.